Morning, guys. Apologies I didn't get this video up yesterday, but I am getting it to you right now, okay? Let's go over a couple things, okay? So as we go through the patterning unit here, we're just taking a look at some of the big ideas with it, okay? So just kind of keep that in mind if you know, going back to that 4-step, right? The pattern, converting it into a table of values so we can graph it, and then being able to write an expression for it. Okay, that's really all we're going to do this year. It's what you need for next year. Okay, so let's take a look at the expressions. So we've got the 3 different patterns. We've got a geometric shape growing pattern. We've got a numerical pattern for example 2, and then we've got like this kind of diagram of, I guess, of these increasing sticks here. Okay. So one of the things that's going to be really important is to find the difference in terms of how this pattern is growing, okay? So our first term is 2, our second term is 4, our third term is 6, okay? So I'm going to start there with 2, okay? And because we're going to use n here as our term number, I'm going to use that as a variable, okay? So let's just start here. Let's just go ahead and put this in here, 2n, okay? So we've got 2n there. Now, if we were to put in, because essentially what we want to do with this expression is find out what the value is, right? And by plugging in the term number into the variable, okay, we should be able to do this, which is just a simple multiplication, and find out what that term value is. Okay, so let's go ahead and try that. So we have 2n. Now if we put in, if we did it like a guess and check on 2, 1, so 1 would be our first term value. That's going to equal 2, even though we don't have an equal sign in an expression. I'm just kind of putting it there to show you. Okay, so that works. Let's try the second one. So get 2n would be 4. 2n. So that looks like it works in terms of an expression, okay? 2 times a number, all right? So for this right here, this growing pattern, how we would express this, 2, 4, 6, if we were looking for, and really why we turn these into expressions, is what if we had a question where, you know, what was the ninth, or the value of the 9th term, the 9th block. So you didn't have to build it all. This would be like a shortcut, all right? So what we would do is we would basically just have 2n, and we would plug in this 9, and then we get 18. If we went on and we built it, the 9th term, 1, 2, 3, 4, 5, 6, 7, 8, 9, this term right here, that term right there, that imaginary term, you know, is going to have 18 pattern tiles here, okay? So really that's the question. So what is the value of the 9th term? It was a question mark, but now we've used this and we've figured it out. So there is an element of guess and check, but hopefully we see a pattern in terms of where the difference is in between the values, and then where we see that in the expression, okay? So let's go to the second one. Second one, we had term 1, which was 4, term 2, 9. So we have 5, okay? So I'm going to do the same thing. I'm going to go ahead and put that into the coefficient there, okay? So 5n, okay? Let's try that now. So 5n, so if I do 1 equals 5, okay? But my first term is 4, right? So that's not going to work. Let's try this. So if I went 5n plus 1, let's try that. So that would be 5, 1 plus 1 equals, well, 5 times 1 is 5, plus 1 is 6. My first term is 4. It's not going to work, okay? Why don't we try this? So right now what we're using the difference in between the values as a coefficient, and now we're just trying to fiddle around with a guess and check to find an expression that works here. What if we did 5n minus 1? Let's try that. So 5n, let's see if we can see here. So 5n minus 1. We're going to put in term 1 minus 1. So that's 5 times 1 is 5 minus 1 equals 4. Well, hey, that works. That is the value of our term 1. Let's try a second one. 5, put in the term numbers 2 minus 1. 5 times 2 is 10 minus 1, 9. Okay, so now we're seeing that this probably works here, okay? So let's say you were looking for what is the term value for the 8th term. Well, you can easily do that, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8. This one right here. But if we just use our expression, let's see how we can do that. So we're going to have 5. That's the difference. That's going to be the coefficient. We're going to have n minus 1. So we're going to have 5. Okay, the term number is 8 minus 1. So we're going to have 5 times 8 is 40 minus 1 equals 39. Okay, so we've used this 5n minus 1 as our expression that allows us to find out what the value of terms, larger terms, are going to be. In this instance, I wanted to know what the term value is for the 9th term, and I was able to do that with 2n. 2 times 9 equals 18. With this one, I wanted to know what the value is of the 8th term. I use 5n minus 1. I plug in. Remember, plug and play here. That's it with algebra, right? As long as we get the right expression or equation, we just plug it in. 5 times 8 minus 1. 40 minus 1 is 39. And that makes sense. Ask yourself, does that make sense in terms of the pattern that we see? 4, 9, 14, 19, right? You know what I mean? That next thing, we've got 39. That looks like that's going to work here, okay? Okay, let's go to the last one here. So first term, excuse me, first term was 4. Second term value is 7. And third term value is 10. Okay, so we've got a difference of 3 here. Let's just go ahead and just use what we've been doing, right? Let's go ahead and put 3n. And let's see if that works, okay? So 3n. Okay, so 3 times 1. Well, our first term is 4, so that's not going to work, okay? Why don't we try this? Why don't we go 3n plus 1, because we know that our first try here gave us a value that was less than the first term, so we can try addition because we know it's going to move it up. Also, that 1 right there is really important because really this pattern kind of grows by 3s, all right? And you've got this one constant here. Sorry. You've got this one constant here, okay? So we'll consider that have a constant. And then we're increasing by 3, okay? Let's just double check this and just see if this works, okay? For let's say the third term, okay? So we're gonna go 3n plus 1. We're gonna go 3 plus 1. 3 times 3 is 9 plus 1 equals 10. That comes back there. That makes sense. So really 2n, 5n minus 1, and now 3n plus 1. So those are our 3 expressions that we get. Now let's say, let's just do it right here. So let's say we were looking for the value for the 7th term. We don't know that, but we can just plug it in. Okay, so if we bring it over here, we go 3n plus 1, 3, 7 plus 1. 3 times 7 is 21 plus 1 is 22. Okay, so there we go. Now it looks like it's going to make sense here. That's all we do here, okay? In terms of finding the expression based on what our term number and term values are here, okay? Now, I'm going to turn over. I'm actually going to stop this video, and then I'm going to post another video really quickly explaining what your question is, okay? So this is the crazy taxi challenge, but I'll show you in a minute, all right? So hopefully we get this. The last thing I'll say is this is where I want to do some video conferencing. with the class, because I've already received 20 responses, with 18 of them being in favor of video conferencing and 2 being not. I want to just let people know that if you don't want to join one of the Google Meets that I think we're going to do, you don't have to. I'm still going to post the videos. I'm still going to be open to email and instruction, but this is the perfect time here where we could open up a little bit of a question answer, okay? But I'll talk more about that as the week goes on, okay? So have a look at this video, check your answers, and then we've got another video coming up where it's going to have your question for the day. The picture transformations are being graded. Just check that. I'm going to submit it back to you. And the rotations, it's due today, so hopefully get that in. If not, tomorrow, not a big deal, but just get it in, okay? Thanks, guys.